So for this rig, we have this setup for the spine. So we have a spine IK, which contains a start and end at the tangents of these is a spline IK using a curve. So that means if I move this one is this curve, and then this one is this curve, I can rotate and I can just adjust the positions using the tangent controllers as well. But also I have the FK option, which snaps into the position. Oops. So spine KFK, and then here you go. There is your, it gets a bit crazy, some of the controllers, but basically this is your normal standard FK spine that just works as an FK chain. So this is very similar to what we've done with the IK FK legs and arms. But this is instead of using the two joint IK, we are using a spline IK, which is actually driven by a curve. So let's have a look at the forward spline IKFK, as I name it, function. So here, these are just the visualizations. We'll talk about this later. But yeah, basically I have a branch. So the items I have in here are the joints, IK controls, AFK controls, a boolean for switch IKFK, and a boolean for stretch. So all of my controls live under the spine group control here. So let's have a look. So if it's true on this branch, I'll do a spline IK. So it's easy if I debug here, and then you can see that it creates actually a curve. So this is what's happening. It's creating a curve from the bones position. And then as I move the controller, it actually moves the curves and then moves the joints with it. So what I'm doing here is that I'm getting the IK controls, which are these ones, the start tangent and an end tangent. And I'm passing the joints. So in this case, it's really all the joints from this chain. So let me open them here. So yeah, just pass all the joints that creates this chain. Doesn't matter that you only have 4 IK controls, because this is the information we need to actually create this curve. So I have a stretch option here, so I'm getting the stretch control and connecting to it. And then you have to work out here the axis, the work. These are the primary and the up axis. You can also create this second spline if you want. That's just a debug visualization basically. So the mode I use is normally I just go for B spline and keep 16, which is the default. So this is how the IK setup works in this situation. And then what I'm doing is that I'm just copying the position to the FK controls. So in this case, if I switch to the FK mode, the joints will keep the same position. So I'm getting the joints, I'm getting the transforms from it, and then I'm getting the FK controls and I'm setting the transform on them. Because I have the same amount of FK controls, is the same amount of the actual joints that I have, that would just basically work because it's 1-to-1. I'm just trying to place all the FKs in here. And then if it's false, I want to actually have an FK chain. As I said, just a simple basic FK chain. So I'm passing the joints and I'm passing the FK controls. And the problem here is not the problem, but the amount of work that goes here is actually when I'm in FK mode. So let's just switch here to FK switch. So if I'm in FK mode, you see that it became all bold, the lines here. And if I start playing around with these controls, how am I going to place the IK controls here in a way that will keep this shape? So what I've done is that I've done a bunch of calculations here to calculate, basically I'm get all the joints, the arrays, and then I get the first joint basically would, so the first joint of the chain, which is this one, I'll then set as, sorry, let me explain again. So I'm getting the joints, which is an array of many joints, and then I'm setting the transform array to the IK controls, which I know there are only 4, because the IK controls will always be 4, at least for this setup of them. So for the first control of the IK controls, which is the start one, I want to actually be placed exactly on the same place as the first joint, right? So this is quite easy. So what I do is that I get the joints array and I create an at with the index 0. So that means that is the first joint of the array. And then I get the position of the first joint and I pass the transform to the first controller. Done. Then the same thing for the last joint, right? So I want the end IK control to be in the same position as the last joint. But because I'm not sure of how many joints I actually have on this chain, as I said, you can put as many joints as you need. So I'm getting this num, which gives me the amount of numbers into this array. And I subtract 1 because in an array, you would see here that the first array is 0. So when I put the information, when I put the node num, it's giving me that this array has 7 items, which is 1, 2, 3, 4, 5, 6, 7. But I actually want the last one. So that means that I have 7 minus 1 will always give me the last joint of this chain. So this is what I'm doing here. So I'm getting the last one of the chain, and then I'm getting its position. I get transform bone, and then I'm passing to the last IK control. So then to calculate the information for the other 2 controls, which are the tangent ones, what I'm doing is that I'm getting the position of one of these joints in the middle here. The calculation I came across and that kind of worked is, again, if I get the number of the total array here, which in my case was 7, and then if I divide it by 3, so 7 divided by 3, it gives me it doesn't break the number, so it gives me a result as 2. So then I'm using that as my at array. I'm using that as my index. So I'm getting the joint 2, which is actually the spine underscore 3. And then I'm getting the information of the spine underscore 3, and I'm passing to the first control, the first tangent. And for the second tangent, I'm getting this result, and I'm multiplying by 2. So I'm getting the other average point, which is the spine 5. And then I'm passing the spine 5 as the second tangent here. And this is how the the spline IKFK works. Also, as part of the spine, I have the cog control and the pelvis control. So basically, the cog control is the one that it's, oops, sorry, here. So the pelvis control is actually the one that moves the actually pelvis joint. On this case, I'm not using propagate children because I want to have the option to isolate this movement. If I want to have some sort of just like a little hip movement, I want to have that option. So my pelvis is independent in here. But I also created another control, cog control, which actually drives all the other chains that we talked before. So leg IFKs, spine, arms, and pelvis are all under the cog control. And what I've done here is that the cog actually also moves the pelvis. So I can move everything from this control, the cog, or I also have just the pelvis control, which just move the pelvis without changing the children or anything. And this is actually the first thing I'm calculating in the rig. So I create a bunch of sequences here just to makes it be easier to read. But the first thing I'm calculating is this whole spine setup. And then I calculate the clavicle. Then I calculate the arms. Then I calculate the necks, the legs, sorry. And then we'll talk later about the whole neck, heads, and facial setups.